Welcome to Building on Bedrock, Elixir's fundamental design advantage. Raise your hand if you've heard of the story of the Princess and the Pea. All right, at least maybe everybody has, but it's in my notes to tell you about the story, so I'm going to tell you anyway. So for those who don't know it, the short version is a princess arrives at a castle claiming to be royalty, and she wants to marry the prince, but the queen has her doubts. And so to test if she's a real princess, the queen secretly places a single pea under 20 mattresses and 20 feather beds, where the princess is going to sleep at night. And in the morning, the princess complains that she couldn't sleep because something hard kept her awake all night. And the prince marries her, convinced that only a true princess could be sensitive enough to feel something so small through so many layers. So how does this relate to software? Well, software is the princess, right? Well, in real life, programmers are princesses, but for this analogy, software is a princess. And our applications feel the effects of bad foundational decisions through 20 feather mattresses and 20 feather beds. So let's take a look at some of these examples of foundational decisions. We have our infrastructure, we have the hardware and OS, we have the build process, we have the runtime where our software is running, we have the programming language we actually use, we have the dev tooling around that programming language, frameworks and libraries that we use to design our applications, architecture of that software, and even the community. Like, can we get help? Are there books about stuff? Can we hire people? All these sorts of things. None of these things are our actual applications. They're not the thing that we're trying to make, but they are the foundational choices that we have to make anytime we do this. So, I'm here to talk to you about Elixir. So, show of hands, who's heard of Elixir? Okay. Now, often when we talk about Elixir, we talk about a lot of different things that it's built on top of. So, show of hands if you've heard of Erlang. Okay. OTP. Okay. The Beam VM. All right. Here we go. Okay. So, a lot of talks about Elixir do a sort of deep dive on the history of the language, some of those technologies that we just talked about, how we came to be here. And I like to think of this as sort of our heritage as Elixir developers. However, I think this can often be a little overwhelming when we're trying to explain what this technology is. So today, we're going to skip the history lesson. We're going to talk about the properties of Elixir as it is now. But it is worth knowing that this technology has been built up since the 80s on very, very solid foundations, and it's only gotten better since then. So let's talk about some foundational properties of Elixir that lead to significant positive effects in the software that we produce. But first, you should understand I'm not trying to pitch you on like some pioneer level stuff. I'm not trying to convince you to be the first early adopters of a programming language. It's in use by companies like Discord, Toyota, Square Enix, Remote.com, PepsiCo, BBC. These are large, multinational mega corporations, effectively, that are using Elixir for tangible reasons, for problems that only Elixir can solve. And ultimately, Elixir is for building scalable and maintainable applications. So let me give you an example before we dive into some technical stuff here. The BBC, heard of them? So they serve 600 million unique monthly page viewers. They reach 81% of people who are over 16 in the UK. And they are the number 2 largest English language news site in the world. And every time you load a page on their website, you go through Elixir code. Then there's a reason for that. The scalability and maintainability of Elixir is directly related to that. Now, a little bit about what I do. We're actually not going to talk very much about my specific area within Elixir. But I do want to give you some context. I build a framework called Ash Framework, which is a declarative application design framework. We generally pair it with Phoenix, which is a web framework. And I'm responsible for a long list of packages, millions of lines of code in Elixir, both open source and in production. And so I have seen all of these things firsthand. Let's get to the good stuff. There are 4 particular things we're going to talk about today. These aren't the only things that I think are foundationally excellent with Elixir. These aren't the only things that lead to significant flow-on effects for us, but these are 4 of them. So, immutability, the concurrency model, dev tooling, and macros. Macros might be, if you are familiar with Elixir, macros might be a controversial one, but I think they're pretty important. All right, let's take a hard left and show some JavaScript. So I have a question. This is some very simple JavaScript. We make an array, we put 1, 2, and 3 in it, and then we make a new array here. We say array.concat 4 and 5. What is array after we read this second line of code? Anybody? Who thinks it's 1, 2, 3, 4, 5? The variable array. If I said array and I console logged it, who thinks it's 1, 2, 3, 4, 5? No? Okay. Who thinks it's 1, 2, 3? All right. So that's right. It's only 1, 2, 3. We didn't mutate the array. How about now? So basically the same code, very similar. But instead of saying array.concat 3 and 4, we say I want to get a new array that's that array reversed. Who thinks that array is 3, 2, 1 after this? Right? Okay. So this is really interesting, and essentially what JavaScript developers have done is memorize the standard library about what does and doesn't modify or mutate the things, the functions that they call. This is extremely difficult, and this essentially means that functions are no longer black boxes, right? You have to fully understand everything that might happen with the things that you pass around in your system. So let's look at Elixir. This line cannot ever change the value of list. It's just not possible. It will never happen. And what this gives you is something called local reasoning, which means I can read any given piece of code, and I don't have to understand every function that it calls and every possible way that it might use the variables that I pass around. And this is very important. Now, if you're familiar with the sort of, with maybe the deeper technology of programming languages, you might ask things like, what about copying, right? Like, isn't that super inefficient if I'm always passing every value around? That might mean I have to copy this value from place to place. I'll show you a tangible example here. Don't worry too much about this code. I'm going to walk you through it. But the shape of this is we create a map that has 100,000 numbers in it, right? It's just the integers 1 to 100,000. And we can ask the system, this is not a function you would ever have to call in real life, but we can ask it, how much memory does this thing take up? And you can see this takes up 200,006 words, right? That's 6 words for the map and 200,000 words, 1 or 2 for each integer. So now I make another map, and I say, okay, I say map.put, and I make a new key called more numbers, and the value of that is data.numbers. So that's all of those 100,000 numbers again. So the question is, how much memory does this new map take up? Who has a guess? Do they think it's roughly 400,000 words? No. It's 200,008 words, right? So that is the 2 additional words required to store this other key in the map. But because Elixir is immutable, it can do something called structural sharing, which means that when you reference this same value all over the place, because you're not managing your own memory in this model, all of it is references to the same places in memory. So if I go and add 2 more numbers to one of those lists, I don't make a new list with 100,002 things in it. Like, to me, it feels like I did, right? As the programmer, I get to feel that simplicity. But under the hood, it's a reference to a big list with 2 more numbers in front of it. So very powerful, and often people think that immutability makes it difficult to write efficient algorithms because they think, well, how do I make sure it's not copying anything, right? It's actually quite the contrary. With this property, we can write very memory efficient algorithms without ever having to worry about it. So you only need to think about values. Under the hood, everything is references. We get this property of structural sharing that works across every type of term or value in Elixir, and memory is efficiently managed for us. So back to local reasoning. It equals less bugs. In general, it's just easier to think about code. Easier code review. A lot of times in code review, what makes it difficult is not the code that you're looking at, it's the code that you're not looking at, right? So somebody wants to make a change to this function, you have to think, well, what else does this mess up? In Elixir, it's very easy to determine that, to ask that question. Fearless refactoring. It's, as you know that everything is a true black box and that nobody's going to be mutating or modifying your values, so you're free to rework the sort of inner workings of any piece of code that you have. And ultimately, it leads to happy developers. And this is something that we hear quite often. Elixir developers are very happy with the software that they produce, and they're happy maintaining it. So immutability means simplicity at the end of the day. And let's look at how this comes out in practice. So Discord This is from a case study that they've done. You know, the numbers might not be exactly right now, but 5 engineers managed 20 plus services across 400 plus machines. It's just 5 engineers. That's all that it took to manage like the massive scale chat that goes into Discord's chat services. And remote.com, this is on the exact opposite side of the spectrum. So remote.com, for example, is not like, so Discord is a very technically complicated piece of software that has to manage this like complex distributed chat room presence concept. Remote.com is actually quite different. It's a very simple site. What they do is they help manage employees for, you know, employees employed like internationally, right? So if you are a US company and you want to employ somebody from Austria, then remote helps you with that sort of thing. The code is not technically complex as in algorithms or anything like that. What's complicated is that they have tons of code about the rules and regulations of what does it mean if you hire somebody in Austria, and like what are the tax rules and so all these like workflows, just lots and lots of code. And they have 200 engineers that manage this stuff, right? Because it's just tons and tons of writing out workflows and managing the changes as the laws change. But they run their entire infrastructure on 5 pods. This is like an international company servicing lots of people all over the world. And each of those 5 pods has 10 gigabytes of memory, right? So very different, almost the opposite of Discord, right? And their engineers are quoted saying, "I feel confident making significant changes in the code base." When have you ever heard of an organization with 200 engineers where somebody said, "I feel confident making significant changes in the code base"? It's just unheard of. Okay, moving on. We're going to talk about the concurrency model. This is Python, not Elixir. We have an example of a very imperative model of concurrency here. So we make a global variable here, balance. We have a withdrawal function that it's going to check and see, well, hey, is there enough money in this account? And if not, if there is, it's going to withdraw that money. And here we start 2 threads, and we say, hey, withdraw $60 from this account. Now, technically in real life, this is a very simplified code example, and it may actually be deterministic because Python has a global interpreter lock, which is not super important. But in general, threads are not safe to use this way, right? So what could happen, if we go back to this example, is both threads at the same time check the balance, and then they go to and they say, yeah, there's plenty, and then they go to the next step, and they both withdraw 60, and now balance is negative 20, which it was never supposed to be able to be. And so you have to be very defensive with this model. Moving slightly away from concurrency, we're going to talk about Ruby. In Ruby, everything has a self, and every self is an object, right? This is pretty much the fundamental tenet of how Ruby works. So here we make a new class called dog, and to bark, say, put out the string that contains my object ID. And we can make 2 new dogs. So we make Fido and Spot, and we tell them to bark, and we can see those 2 things are objects. So self is always an object. So couple these 2 things together, the sort of complex and imperative concurrency model I showed with Python, and this idea that there's always a sort of self, and you get to something like Elixir. Except self, instead of being an object, self is a process. Okay? So this is an example of a module in Elixir. It was kind of Ruby-ish. It's really the only way that they're related for the most part is there's some syntax similarities. But what we have is we have this function called loop, and all it does is it waits to receive a message. So it says, hey, I'm going to just sit here and wait until somebody tells me to bark. And then after it's done, it just calls a loop, which calls itself again. And this is the fundamental structure for a process in Elixir. It's just a loop that's waiting for messages, and when it gets a message, it'll do some stuff. And we, instead of saying .new to create a new object, we say spawn, which starts a new process. And now we can send a message. We can tell Fido to bark, and we can tell Spot to bark. A big difference between the Ruby model and this model is that those 2 processes are running completely concurrently, right? They will use multiple CPUs. I could send them 1,000 messages, and they'll all get queued up, and they'll all happen concurrently. Now, this is a really low-level example. I've shown it so that you can kind of understand what a process is. It's just this simple loop that's taking messages and doing some work. We have nice abstractions. You don't need to worry too much about them. I mostly just want to show you so you don't get afraid of having to write the word spawn a bunch of times and think of like, oh, I'm very imperative. So you can just say, yeah, here's the server in my application. Like a little tiny microservice that runs fully concurrently within your app. And I can say, look, you can tell me to bark, and here's what happens when I bark. And now other people can say, okay, we'll make one of these new services and tell it to bark. So, Elixir is built up of lightweight processes. Each one of these processes takes roughly 4 kilobytes of memory, and it is standard to have like millions of them running in your application, right? It's extremely cheap. They're not operating system level processes. They are a language level or a virtual machine level concept within the not giving you a history lesson, within the Elixir's virtual machine. So we have a bunch of processes here, but they have isolated memory, right? So they do not have mutable state. We've already talked about immutability, but you also cannot just pry open a process from some other process and say, well, give me your data, right? They have isolated memory, and they communicate via message passing. You saw that when we told our dogs to bark. We said send to send it a message. So process 1 might say start import, and process 3 might then say, okay, we're going to import this, number 1. And then that might send a message to process 1 and say, hey, we're imported. And this is actually the architecture that we use when we build a lot of the things with Elixir, this process architecture. You can do a lot of really important things with processes that make it really powerful. We can link them, for example. So let's say process 2 and process 3 are linked, and then something goes wrong, and process 3 goes down. Well, process 3 tells process 2, hey, we're going down, and process 2 goes down too, right? So you can create failure boundaries within your application of the various things that are running inside of it. And we actually compose on this concept of links to build things called supervisors. And this is just provided by the standard library. Very, very easy to use. And we can say, hey, I've got these 3 processes running, I need you to keep them running, right? And you can configure it a little bit to be smart about how it does that. But in this world, something goes wrong, this process crashes and it goes down, and the supervisor gets a message, and nobody else is affected. All these other workers, all these other things, they are fully isolated from that failure, and the supervisor says, okay, well, let's start another one. Okay? So we can create, not only can we create failure boundaries, we can create this resilience layer that will restart the things that fail in our application and get them back to a known good state. Now, this one's a little bit headier, but it's actually really important to the way that the system works, the way that Elixir works, is this concept of a preemptive scheduler. So when we talk about concurrent programming, in languages like I showed with Python, for example, where we're starting threads, imagine we've got two processes here, or 2 CPUs here, and we've got 2 processes running, and they both make these really chunky requests to the CPU. They say, I need to do a lot of calculation, and I just need to keep doing it. In a model where you're essentially claiming the CPU to do your work, if then process 3 comes in, and let's say process 3 is like an HTTP request from a user, right? These are like background jobs, and this is a user making a request. Who does it talk to? How does it get any work done, right? It's not possible. The only 2 CPUs in your system are busy right now. And you can actually do this. You can simulate this really easily with Python, with JavaScript. Just do a bunch of really CPU-heavy work and watch things sort of grind to a halt. So in Elixir, we have these things called schedulers. This is all transparent. You never have to actually know how this works, but it's important for you to understand you can do this sort of fearless concurrency, and that's because of the way schedulers work. So instead of calling directly to a CPU and saying, I need to do a bunch of stuff, we work with schedulers. And so now process 3 says, hey, I got a little bit of work I need to do. And this scheduler can actually stop the work that this other process is doing. And it's safe to do so because that process has isolated memory and a mailbox that it uses to communicate with other things. And so nothing is reaching in and screwing with it. It's not relying on being able to mutate somebody else's state or anything like that, which means any process anywhere can just be paused for a little bit and nobody cares. It's not a big deal. Your program just keeps on trucking. So that's what happens. So process 3 comes in, it does a little bit of work. The HTTP request comes in, is served and goes away, and your background work keeps running. And this is one of the things that actually makes Elixir extremely efficient, because you can just run tons of stuff, and it's all going to fill up your CPUs, and it's going to use it all the way up to 99%. But you still get it. You can still serve traffic. You can still serve on-demand traffic and burst traffic because the schedulers make sure that everything makes progress. Right? No one thing gets to claim a CPU for 10 minutes while everything else just waits. Okay. So, concurrency model is scalability and reliability. Let's see how we're putting that into practice. So Veeps is a music streaming company or like an event streaming company. You watch like concerts online. They have very high traffic, and they were running their service with 20 Rails nodes, and they were having problems, even with 20 separate Rails machines. They rewrote it in Elixir, and it took 2 machines. So that's 10x performance gains. But during that time, their actual requirements grew by 86 times. So they went from 20 machines to 2 machines and served 86 times more traffic than they were serving before and had that much more capacity, right? It's extremely efficient, and you have to see it to believe it. It's an entirely different way to compute. And X-Plane. This is like a multiplayer flight simulator tool. At least they were doing some multiplayer stuff here. And they wanted to have 10,000 users in one single multiplayer session that were all doing flight simulator stuff. And then, of course, they chose Elixir. And they had a bug. And they got 1,000 times the traffic that they meant to get in this process. And this was because essentially they've got flight simulators running on people's computers, right? And they're checking in, and it was just like a misplaced decimal point. And so they're checking in like 1,000 times more often than they're supposed to check in to tell the server about what's going on. Nobody noticed that this was happening. It just went fine. They went from 5% CPU load running this 1,000 or 10,000 user multiplayer session to 25% CPU load, and they just happened to notice it on their charts, and were like, huh, what's going on, right? And this resilience is something that I've seen personally when I have traffic spikes. I had a website that got posted on Hacker News, and I didn't find, nothing happened. It didn't get slower. None of my metrics were affected. I found out because somebody sent me an email, right? And if anybody's ever seen the Hacker News hug of death, it's pretty brutal. It doesn't happen to Elixir apps. Okay. Yeah, moving on. Dev tooling. So one of the things that Elixir has very much in its corner is for a lot of these dev tooling type things, there's really only one way to do something. Not because they want to stop you from doing it another way, but because the core language maintainers and core maintainers of projects just thought about it and made the one right way to do it, and nobody needs another way to do it. So we don't have this like, do I use Webpack or Vite or Bun, or do I use like pip or like, I don't know what the Python world is doing these days, right? But we just don't have this level of fragmentation of tooling, despite having a lot of people using this in production. So to do things like run tests, you say mix test. There's various tools to maybe help you write a different kind of test, but in general, all tests in Elixir look the same and use the same tooling. If you want to have documentation for your tool, you say mix docs, and that generates documentation from your code, and we all use the same tools, and when you publish a package for Elixir, it all goes to the same place. It's called hex docs, and I can go to any package and I can search the docs. It all uses the same interface. There is no worse or better docs. I don't have to go find your like personal website for your thing. It just, none of it works that way. You just say mix docs. If you want to format your code, you say mix format. There's like 3 configuration options for the formatter because they realized the whole point for the formatter was to stop people wasting time and bike shedding. And so you say mix format, it works the same for everybody. All of the code everywhere is formatted the same. If you want to work with dependencies, you add a new dependency into this, you call it your mix file, right? You say mixdeps.get to go fetch the new dependencies, mixdeps.compile. There's no custom tooling needed around any of these things. If you want to publish packages, the same thing. You say mixhex.publish. They're all hosted in the same place. They all are checked and secured in the same way. If you want to expose tasks that can be called from the CLI from your application, you define a thing called a mix task in your application, and boom, it's now an executable command from the CLI. So if you download some new package and it has like a little generator you can run, you run the generator. Every single thing is executed in the same way, it's packaged in the same way, it's delivered in the same way. It is just a breath of fresh air. And this one is actually kind of interesting, maybe debatable about if you would call this a dev tool. But as a package author myself, this is actually super fascinating. You don't need to worry too much about the actual code that I'm showing here, but one of the things that you can do, so if you're shipping a package, like a caching package, for example, right? I can say, okay, well, this thing has an application in it, and I need these workers to be running in my end user's application, and I'm just going to say, okay, start a supervisor running these workers, right? So instead of saying, okay, go modify your like main function or your like app initialization or some config file on startup to make sure that everything's started up right now. When you start an Elixir app, all of the applications that are required from all of your dependencies just start on up. So I can actually ship live concurrent code directly into your application, trivially, just by including an application in my package. Debugging and observability in Elixir is just insane. What you can actually get for free to understand about your Elixir application, like zero setup, actually zero setup, you could just say observer.start. That's like the REPL, for Elixir. And you get this GUI that runs on your machine that will give you load charts. They will tell you like every application started. I just showed you that application. It'll show you the processes running and the links between those processes. You can go in and you can see the stack trace that process is at. Like what piece of code is that process running right now? And this is built in. And on top of the tooling that this is built on is even more amazing observability tools. When you make a new Phoenix application, you get a web view for this that you can just mount and put behind authentication or whatever and go to production. And you can see, hey, what's all happening in all of my application. And I think even past that, we have this general philosophy in Elixir that it's an all-in-one ecosystem. We very rarely need to spend money on other tools to do what it is that we're trying to do. A good example for this is things like distribution. We don't need to get Kafka or whatever for message passing so that we can have our application distributed across 10 different instances of running application. No, that comes built in. You just cluster your nodes. It's a feature of Elixir, and it's trivial to set up. And now I can just send messages to other processes on other nodes. I don't even have to know what node they're running on. It's transparent to me. We have a thing called Erlang term storage, so I don't need to pay for Redis maybe you don't pay for it, it's open source stuff, but I don't have to run it, I don't have to operate it, that costs money. Erlang term storage is an in-memory database built directly into the language, so I don't have to deal with any of that complexity. Phoenix Framework is an amazing, best-in-class web framework for building web applications. We have tools like Livebook. Livebook is basically Jupyter notebooks, but for Elixir, with the ability to connect to your actual running application and run the code that you're running, and the ability to use all of the stuff that we've discussed, like distribution. You have to go look at the demos of people running distributed machine learning workloads by starting commands from a live notebook, like a Jupyter notebook, and then having that spin up like massive infrastructure nodes that are linked to this particular notebook and will send back the data after processing it on these like beefy machines. It's insane. They're supervised by the notebook. So if something goes wrong, one of the machines goes down, it's going to start up a new one. It's just, the capabilities here are insane. We have projects like Nerves and Atom VM that let you run Elixir on device. That let you run Elixir on embedded devices. So if you want to run on a Raspberry Pi, or you want to run so that's Nerves for you. If you want to run on like a microcontroller, something that's extremely resource constrained, Atom VM will do that for you, right? And if you want to do number crunching, we have tools called NX. This is numerical Elixir that will let you do things like run numerical calculations directly on hardware, compile them down. We have tools like Axon for doing machine learning and training models. We have tools like Absinthe for building GraphQL APIs. We have tools like, this is a tool called OpenPro, which is a Elixir tool. It's a dependency that you just add to your application that gives you all of the features of like background jobs, like durable background jobs, durable workflows using Postgres. And so I'm going to read you something from Beeps here. This is that streaming company. This is from their CTO, and he says, "Throughout my career, I've never encountered a developer experience as exceptional as this. Whether it's about quantity or complexity, tasks seem to flow effortlessly. The team's morale is soaring, everyone is satisfied, and there's an unmistakable atmosphere of positivity. We're all unequivocally enthusiastic about this language." And developer happiness is very closely tied to developer productivity. That's my part, he didn't say that. SmartRun is a company that's using Nerves, I was just telling you about. They're running on over 3 million connected devices, and these connected devices report back up to home base, right? So these things they have to run reliably out in the field. They're not in a place you can just go like pry open the hatch and fix, right? And so they're running in almost 1 million rental homes, more than 1 million rental homes, and this is all powered with Elixir and with the clustering technology that I told you about and with Nerves. So, dev tooling is I would say most tied to time to value, which is just time not thinking about the crap that doesn't really matter, and the ability to use the same tools that you know to do everything that you might need to do. Okay, we're going to move on to macros. So macros are a really interesting concept. Who's heard of metaprogramming? Who has done some metaprogramming or anything like that, right? So metaprogramming in Elixir is done in a very interesting way, and I think a very powerful way, which is at compile time. So Elixir is a compiled language. Ruby, for example, does metaprogramming at runtime, generally speaking, which makes it actually quite difficult to reason about. Whereas with Elixir, you can compile the application and you can then look and see, okay, well, what does this actually do? And so we're not going to talk about how you write macros, because the truth is, it's an advanced topic, and you, if you decide to use Elixir for some project, will likely not be writing macros yourself, but you will be very grateful that the library authors and framework authors have access to macros to provide you high-quality tools. So this is an example. This is a router. This is what a Phoenix router looks like. You can see you get this really nice little syntax. It's a little DSL, and you say, hey, there's a route at /posts, and it goes to this controller, and there's a route at /post/ID, and it goes to this controller, right? But these are macros, and this compiles down to pattern matching, like the most efficient way that the Elixir language can actually match up, clauses of functions. So you don't have to pay the price of an expressive format for a router or of a performant router, which if you're familiar with writing any kind of router is kind of a never-ending push and pull of these tools. This is what I would call maybe a builder DSL. So this is what it looks like to use a tool called Ecto in Elixir, which lets you build a SQL query using Elixir syntax. And we get this really nice syntax. You get things like validation, that you've used operators that make sense, and that you are selecting fields that actually exist, etc. And then we can send it to the database. We get things like expression DSLs. So this is that NX library I was telling you about. Here we can say defn, which looks like a regular Elixir function, but this is compiled to run on hardware directly, right? And all that sort of magic is hidden from you as a developer. You just get to think about the math that you're doing. And then the macro, the metaprogramming handles it for you. Compile time optimization. This one's a little wild. It's hard to kind of find an example for this that is going to not break too many brains. But this is actually the sort of thing you might do. Let's say at compile time you've got a CSV of some data that your application is going to use when you deploy it, right? You can actually read the CSV at compile time. This happens while the app is compiling. And then we're going to define functions from the contents of that CSV file, right? So we don't pay a runtime cost for this metaprogramming that we're doing. It's baked into our compiled application. And we can get this really efficient lookup of data in a CSV, just like this, by compiling it into the application. We can use it to do things like rewrite code, even more than I was just showing earlier. So this is a function that exists. It's not necessarily the most common way to do this, but it's a good example. If I wanted to write a function that is where the results of calling it are cached, there's a library that provides you a thing called def cacheable, which says, well, hey, whenever this function's called, take the arguments that it uses and go check in the cache first. And if it's there, then use that cache value. Otherwise, run the contents of this function. Very powerful tool. Not necessarily something you want to just abuse, but it really condenses the concept space when you're actually working with these things. And we can use them for compile time safety. This is really important, right? The ability to take errors from the runtime to the compile time is one of our superpowers in Elixir. And this is an example that we're going back to Ecto here, where they take this is some user input, right? It's just a variable, it doesn't really matter where it came from. And we are using a thing called fragment. Don't worry about it too much. It just means put this SQL right into the SQL query. Don't sanitize it. Don't do anything like that, right? And you get an actual error if you try to do that. At compile time, your program won't even build if you try to do that. You say, hey, you're putting untrusted input directly into the SQL query, so there's going to be, little Johnny tables, right? It's going to drop your whole database, and you have to do something else, right? And there are ways that you can, sort of manage that, but it's going to stop your naive initial implementation or a junior developer from shipping something that deletes the whole world. Very useful. So, macros are power. So we don't want to use these all the time. We don't want to abuse them, and most of the time you won't be using them, but they allow for these significant transformations in what we build. And let's talk about how this sort of thing is actually used. So this is an example that Remote talks about. So they have 200 engineers working on a really big and complex code base, right? And it's actually just the logic itself that's complicated, not the feature. It's all basic web stuff when you talk about how it actually works. Take a request, do some stuff, return a response, right? But they needed to ensure that the rules that they have about the code that they're building are followed. And there's a couple ways you can do this. One common way to do this is to do like a microservice architecture and make sure it's all split up and have like 50 different services and all this sort of stuff. In Elixir, we generally just never have to do that sort of thing. We don't want to do that sort of thing. But we can actually, at compile time, say, this is a tool called Boundary. It's by one of our sort of Elixir legends named Sasa Jurek. And you should go see his, or Juric, sorry. You should go look at his talk because he does a much better job pitching this stuff than I do. It's called The Heart and Soul of Elixir and Erlang. And this library verifies at compile time that certain modules in your application do not call out to other certain modules in your application. So if some developer tries to break a rule about what code can call what functions in what other place, they get a compile time error and says, hey, we have not stated that you're allowed to call from like the accounts context, the accounts module namespace to the security namespace, right? That's the rule that we haven't said that you're allowed to do. And it's just a couple lines of code to say, these are the boundaries of my system. And this is all managed for you at compile time. It's really powerful stuff. Phoenix is, if you've heard of Elixir, probably because you've heard of Phoenix is why that is the case. They use macros for a lot of the things that they do, and it's mostly transparent to their end users, but it's part of what makes it so powerful. And they have a lot of large companies that are leaning into Phoenix because they get great developer experience and great reliability and resilience. So we've talked about the 4 major things that I think we can get: simplicity, time to value, scalability and reliability, and power. But these all stem back to 4 very important properties: immutability, the concurrency model, dev tooling, and macros. So we're wrapping up. A little ahead of schedule, so you guys will have time to get coffee. How wonderful. But before I get there, I'd like to thank my employer, Alembic, for sponsoring my open source work and my attendance at conferences. Alembic is an international software agency with deep expertise in web development, distributed systems, and wrangling complex software requirements. We combine great people with leading tech to help businesses build ambitious software applications simply, efficiently, and sustainably. So if you're looking for help, you can come find me after this, and we'll see what we can do for you. I also say give a little hand to our sponsors of this conference. Come on, give them a little, there we go. We are very thankful for them. And I would also urge, I did not talk about Ash, despite that being what I have spent the last 5 years of my life building. I kept it very, very civil, and it's not civil, but very focused on Elixir. And the reason for that is that in order to adopt Ash, you have to first adopt Elixir. And there's a reason I built Ash in Elixir. And I think that high-level abstractions on shaky foundations make that even worse, right? So I think that Ash Framework is an example of we can revisit some of these concepts of high-level abstraction that you've seen in places like Rails or Django, and we can eliminate a lot of the complexity and difficulty that you face with those tools by building on a better foundation that is more stable, that is more easy to reason about because of immutability, right? So these high-level abstractions don't give you this spooky action at a distance of like, oh, I called this function over here and it somehow broke user registration or something, right? So I would urge that if you're interested in Elixir, also consider looking into Ash and Phoenix. So here's some QR codes if you want to check them out. They're just links to the web pages for those things, so you can also Google them. And that is all that I have for you today. Do you have any questions?
Do you have any best practices for using LLMs like Claude or something with Elixir and Ash? Because I know it's kind of like Python and JavaScript centric these days.
Yeah, actually. So I specifically am working on a suite of tools to handle that problem. So there's a package available for Elixir called usage rules. And the concept here is you download some dependencies and you run mix_usage_rules.sync. And now this requires that dependency to have done this, to have added a usage rules file, which all of the Ash framework packages have, or all of the bigger ones have. You say mix_usage_rules.sync, and it'll pull in the usage rules that you can then say, you can sync it to the end of your like claude.md or agents.md file to get like the condensed do this, don't do this type instructions for working with Ash framework. And it's a very new pattern, like anything with LLMs, very new. But other Elixir packages are looking to do similar things, and this usage rules is not tied to Ash, it's just an Elixir tool. So yeah, that's my main suggestion. And there's one other thing is there's a product called Tidewave that is very cool, and it can help solve a lot of these problems. It's an MCP server that you run in your Phoenix application so that you can make your agent able to like talk to your app. And one of the things it can do is it gives it a documentation lookup function that can say like, go find the docs for this function. And that sort of stuff really superpowers your LLMs. One other thing on that topic, today, like 2 hours ago, a product called Phoenix.new by a company called Fly.io, which is a deployment infrastructure company, just became open to public sign-up. People have been waiting for this for a long time. It's like a remote LLM-centric IDE for building Phoenix applications. So it's a great way if you're like want to kind of try out Phoenix maybe and try it out with LLMs. That can be a really interesting way to do it. I think it's like $20 a month, so not breaking the bank. But yeah, that's the latest on the LLM scene, I guess, with Elixir and Ash and stuff.
Thank you.
Is there an ORM like active record for Elixir?
So, yes and no. Generally speaking, the most prevalent thing, factoring out Ash for a second, is to use Ecto, which is it's lower level than an ORM, right? You're ultimately composing like database operations, and a lot of people do that with very good success because it provides a lot of utility on top of that process that makes it like you're not composing raw SQL operations, right? But it's slightly lower than what you would typically think of as an ORM. And Ash, actually, I gotta be really careful here because it is not an ORM, like very much on purpose, but it kind of sits in that same area for the Elixir ecosystem, which is these higher level definitions of the entities that you might have in your system and the operations you can take with them and what that ultimately means for how that happens in the data layer, for example. But I would say like Elixir is a functional programming language, and certain things from ORMs just don't quite map to that paradigm. So I would say like, yes, we do have an ORM if you draw a really shady, and squint really hard circle, and I would say that is kind of like part of what Ash does. But it's going to be a little different than what you're used to if you switch to it. So if you're looking for that high-level tooling and that experience, then Ash would probably be something you want to look at, but not exactly an ORM. Yes?
Can you talk a little bit about like common production deployment patterns for Elixir applications? Like, it sounds like it's very different than if a team is producing some Node.js application that gets deployed on a Kubernetes cluster. Like, I imagine this would be very different to run Elixir apps and product.
It's actually not really.
Okay.
And what's actually really interesting is there are some camps, like you will probably find a blog post if you're searching for this stuff that says you don't need Kubernetes if you're using Elixir, primarily because Elixir heals. The nodes are very resilient, right? But honestly, if you're talking, what's the right way to phrase this? If you're at a company that employs a bunch of engineers, and one of them knows how Kubernetes works, and you've got the money to run whatever the cloud, just run it on Kubernetes, it's totally fine. You get a bunch of nice little tooling hanging off the side of that, and we have tools for clustering within a Kubernetes cluster, trivially. You just say, there's a tool called libcluster that says, hey, I'm running in Kubernetes, you use Kubernetes service discovery to find all the other nodes, and then connect these nodes together. So what I would suggest actually is you can deploy it like any other application. But on the flip side, you have some new deployment options if you have more interesting needs, right? So the application will run very resiliently, deployed as a singleton on a Raspberry Pi, so that you don't, which is not something that you can get from most other deployment strategies. So I would say deploy it like you normally do. We have tools, it's called releases is the thing. You say mix release to make a new release, and then you just ship that to Kubernetes, run it on a Docker file. It doesn't really matter. It's all the same as what you do normally.
And you still reap the same benefits that you would?
Yeah,
okay.
Absolutely. I mean, this is one of the things that's really interesting is Elixir was designed to be both distributed and to handle failure, like distributed failures, right? So I would suggest that it's a better fit for things running on Kubernetes, for example, it was designed to operate in that way. So like a lot of the things that we do just work across a cluster like magically. Like, you are going to be surprised. So like we have a thing called PubSub for broadcasting messages for things that have happened. So a new user signs up, maybe you want to send a push notification to somebody or something like that. PubSub just goes to the whole cluster, like transparently. So like you have all of your cluster subscribing to this notification and they just get it. It just works. It's really insane. So it's the only thing I've seen that actually works well in a distributed cluster without needing stuff like Redis or queues externally to it to communicate across the cluster. Like it's just designed to operate in that way.
Thank you.
Yes, well, right behind you actually, I think you have a question, and then we'll go to you.
I'll let you go first.
Okay, go ahead.
So I was going to say, so the Ash is, your framework is about domain modeling, right? And then being able to expose your GraphQL or REST or whatever endpoint. Do you see people using that, like, do people still use JavaScript front ends for that are plugging into an Elixir backend? Or is it like, I know Phoenix has live view. Is that like, what you're talking about with Hex, like everybody's like, yeah, screw all that, we have a, you know, a normalized way of doing this?
No, I would say this is actually one of the biggest things, one of the biggest selling points of using something like Ash, is you get this well-defined application layer whose interface can be exposed to sort of any multiple different ways. And one of the things we found, Elixir has some really interesting and very powerful tools like LiveView that you were talking about that present like a pretty alternative way to build like live reactive front-end applications. That save you from having to do all sorts of really complicated, you don't have to build an API, you don't have to do all this other stuff. It's like, it's handled on the server, it's magic. But at the same time, there's actually a risk in that, right? Which is, okay, you're a year and a half into building your product where it was just a UI, but you don't have any APIs now. Like somebody wants to integrate, you need to have like some third-party service that wants to call you, but you never built a public API because you never had to. Like now you have to figure out this whole new abstraction on top of your existing code. And Ash makes that sort of thing a triviality because, if you're I'm not going to go into explaining it right now, but it does do that. So I would say like it's almost an even split where of people who are using Ash with like GraphQL and React front end is very common. And more we're actually seeing our customers will use LiveView for back-end admin dashboards and stuff because it's just so trivial to make that stuff. And then they'll use a GraphQL in React or a JSON API in React for their consumer-facing applications, primarily because it's so easy to find React whiz kids that can just make beautiful API or beautiful UIs and stuff like that, and they don't want to throw that away for building with LiveView. So
That makes sense.
yeah, cool.
Sounded like you said sort of the dependency management is all centralized, and so everybody's sort of working off of that same centralized thing. Two questions around that. One is, what's to prevent a bad actor from coming in and making a modification to maybe a low level, like we had LPAD, or I think
Right.
back in the day, before in the JavaScript world, doing something like that?
I mean, there are, I know probably more about this than most rank and file engineers because I've published like 50 packages onto this thing, but I would say like I don't know all of how the package manager itself works, but it's a very strictly controlled place where you publish packages. And for example, it like links back to GitHub so you can see like what the diff of all these packages are, and you can't republish an old version of a package like ever. Like you can't, you have a 1 hour window where you can say, okay, actually that thing I just published, I want to rewrite the contents of that package. And so in general, like it's very immutable, very introspectable. So I would say like we don't have a magical solution to the NPM left pad problem any more than they do, but I've found that team to be like really strict in what they allow you to do and what they allow you to upload, and how you can change the contents of packages, which is effectively that you cannot. All right, that's it, we're done.